Hey everybody, let's do some math. Today we're looking at lesson 5, which is titled Say It with Decimals. And two of our learning goals are the same as lesson 4, but the first one here talks about writing fractions as decimals. Our first activity is going to be doing that, and some of you have forgotten, but we have just finished doing some practice here at the beginning of Unit 4 on how to turn a fraction into a decimal. So remember, this fraction bar is also considered a division sign. So we are able to turn this into a decimal by dividing the numerator by the denominator. And the directions say use long division to express each fraction as a decimal. So if we were to use long division, we're dividing 9 by 25. We would put 9 here and 25 here. I know it's been a long time since some of you have done long division, so I'll do the first one here for you. But we're looking at how many groups of 25 we can take out of 9. And of course, the answer to that is 0. We cannot take a full group of 25. So we're going to have to take part of a group of 25. And that's where our long division is going to come in. So we can, with a decimal here, add as many zeros after the 9 as we need to divide this out. So what I'm looking at now is how many 25s can I take from 90? And that would be 3. 3 25s is 75. We subtract to see how much is left, and we would have 15. Since there's still a remainder, I can add another 0, bring that down. And how many 25s can I take out of 150? The answer to that would be 6. 6 25s is exactly 150, which leaves nothing left. And I have turned 9 25ths into its equivalent decimal, 36 hundredths. All right, go ahead and do that for the next two, please. And we will take a look at your answers in just a minute. For 11 thirtieths, you divided 11 by 30, and you should have gotten what I hope you realized was a repeating decimal, 0.36, and that 6 just continues on for as long as you can divide, for as much paper as you have, and it's just going to continue going. So once we see that number repeating, we can stop and we can put a symbol above that number that's repeating. That line, that bar above the number tells us it's just going to go on forever. The same for 4/11ths. You got another repeating decimal, and when you divided 4 by 11, you should have gotten 0.36 repeating. But the difference here that you would have found is that the 3 and the 6 are both repeating. So we basically have the same answers to these three fractions. They look very similar to one another. The next question says, what's similar about your answers? Well, they all have 36 hundredths, a 3/10ths, and 6 hundredths in the answer. But the next part asks to order these with the greatest value. Which has the greatest value? So these are not the same answers. This repeating amount changes it very much. So if we look at the first one, 0.36, and then we look, and that was 9 25ths. If we look at the next one, 11 30ths, we get 0.36 with the 6 repeating, and with 4 11ths, again, we get 0.36. Now, when we're comparing numbers, it's always best to line them up based on their place value or line up their decimal points because it helps us compare much easier. So I can see there's no whole number values for these three numbers. The tenths place, which is the next largest place value, is all the same. They all have the same 3/10 there. If I look at the hundredths place, that looks the same as well. They all have 6/100ths. So in that sense, they all have the same value. But not all of these numbers stop there. If we were to continue and go to the next place value, the thousandths place, well, if I had to put a digit here for the thousandths place in my first number, the only thing I could put there would be a 0, because there's no other amount to put there. But if I put a 0 there, it doesn't change the value. If I look at the next one, remember, if you had a calculator screen, you would see that 6 continuing across the screen of the calculator. So here in the thousandths place, there is a 6, even though we wouldn't write it because of this repeating bar that we put as a symbol there. And then if we look at the next one, the 3 and the 6 are both repeating. So across the calculator screen, we'd see 3, 6, 3, 6, 3, 6, 3, 6, as much as it could show. So if that pattern continued, the thousandths place would have 3 thousandths for this number. Now, when we go to the thousandths place, there's definitely a difference in the value. You can see that 11/30ths has the greatest value because there's 6 thousandths here at the end of the decimal. And then 9/25ths is the smallest because it has nothing there in the thousandths place. The number has stopped. All right, let's continue on. For our next example, this is a lot like what we were doing in lesson 4. It says Kieran read for X minutes and Andre read for 5/8 more than that. Write an equation that represents the number of minutes Kieran read with Y, the number of minutes that Andre read. Use decimals in your equation. And that's what a lot of today is. It's going back and forth between fractions and decimals. So please get comfortable with that. Use your Desmos calculator if you need to. But certainly some of these fractions you're going to be able to just look at and know what their decimal equivalent is. So let's write an equation. So if you remember yesterday, we talked about those diagrams. And we would have an amount that we would call X. And then we'd have another amount listed below it that was our Y value. And sometimes the Y value was greater and sometimes it was smaller. In this case, looking at the problem, if Kieran read for X minutes, Andre read for 5/8 more than that. We're always looking for those key words. So 5/8 more than that is going to show an increase in what Andre read. And because we're looking at 5/8 as our fraction, we need to take our X value and split it into 8 equal parts. Now that whole amount is going to represent Kieran's reading, his X amount there. That's the 8/8. So we have 8/8 of X for Kieran. And then we have 5/8 more for Andre. So we'll take this next part. We still have all of the 8/8 that Kieran read. And then we have 5/8 more to represent the total amount for Andre. So combining those, our Y amount is going to combine the 8/8 from Kieran, the extra 5/8, which we can put kind of like this, the extra 5/8 for Andre, and now we need to write our equation. So our Y amount is greater than our X amount. It's greater than our X amount by 5 more eighths, which would give us a total of 1 and 5/8, or we might say 13/8 would be another way to say that. And using an improper fraction here is totally fine. That's the 8/8 plus the 5/8, 13/8. So both of these are equivalent. The big thing here, though, is it said use decimals in your equation. So we're going to have to bounce back and forth between those. All we've got to do is divide. So we're going to divide 13 by 8 to get that decimal point, to get that decimal number. And since this is an improper fraction, it's going to be a number greater than 1, and that would actually be writing the equation as y equals 1.625x. That would be the decimal equivalent of 13/8 or 1 5/8. Let's continue. For the next activity, we've got some more diagrams like we just talked about. We are matching the diagrams with a description, which you can see here in this column, and an equation here in this column. So let's look at the first diagram, diagram A. Now, the trick with today's lesson is we're not always going to be starting with the x value. If we look at the descriptions here, some are increasing and some are decreasing. And there's actually going to be 2 descriptions that fit diagram A, depending on how we look at it. So typically, if we looked at what we did yesterday, we would see our x value is all of this diagram, all of this bar here. Our y value is less than that, so we're going to decrease the x amount. And you can see just by how it's split up, if our x amount is split into 4 parts, then our x is 4/4, and we're going to decrease it by one of those parts, by one of those fourths, in order to get our y value. Well, decreasing by 1/4 would be listed right here. So that would be for figure A. But we can also look the other way. If we compare to the y amount, well, y is made up of only 3 of these parts, so all of y is 3/3. So 3/3 for y. And then to equal the x amount, we need all 3/3 and an additional 1/3. So that would mean that we are increasing y by 1/3. I know it seems kind of weird to look at it from each direction here, but that is 2 ways that we could represent what's happening in that diagram. It just depends on if we're comparing to x or are we comparing to y, depending on which of these descriptions you would use. All right, now if we look at the equations though, they are all written the same way. We have our y value is equal to a constant of proportionality times x. So if that is the case, then we have to look at it as this description here, because we're going to equal the y value by taking all of the x value and removing part of it, by decreasing it by 1/4. If we decrease it by 1/4, remember yesterday, we take all 4/4, we remove 1/4, we're left with 3/4. But notice that all the equations are here in decimals. So we need to know what 3/4 is as a decimal and use that as our equation. And that would be right here. Y equals 0.75x. All right, now take a moment and look at B. And let's determine the 2 descriptions that are going to describe figure B, and then we'll find the 1 equation that would represent it. For figure B, if we look starting with the x amount, x is made up here of 1, 2, 3, 4 parts, 4/4. And to equal y, we would have to increase it another part, another 1/4. We'd be increasing by 1/4. So for B, we would use this description here, an increase by 1/4. Or if we started by looking at y, we would have to decrease it by 1 part to equal what x is. If y is this total bar, 1, 2, 3, 4, 5 parts, then y would be 5/5, and we would remove 1/5 to get down, remove 1/5 to get down to where x is. So there we could say we could decrease by 1/5 and also describe the same situation. But there's only one of those situations, one of those descriptions that's going to match the equation. Remember, here we're altering the x amount to equal the y amount in the way these equations are written. So we need to equal the y amount, which means we need to increase x past the 4/4 to an extra 1/4. So we're going to need a constant of proportionality here greater than 1. It's got to be one of these numbers larger than 1. And if we're going to increase it by 1/4, then we need 5/4 of x to equal what y is to get all the way down here. 5/4 is also 1.25. So that would represent figure B. Let's take a look at the summary for today's lesson quickly before we do just a little bit more. It talks again about our goal, our learning target, our learning goal, which is understanding half as much again and multiplying by 1.5 mean the same thing, or multiplying by 1 1/2. Talking about repeating decimals. Remember, repeating decimal is an infinite decimal expansion that eventually repeats the same sequence of digits over and over again. The repeating sequence is indicated by a line above it, that bar that tells us it's a repeating number and tells us what numbers are repeating. So as we look at the next part where we're matching equations, more equations to situations, just a quick reminder that when a situation says less than or something about a decrease, we are talking about subtracting from the whole, subtracting from 1. That's why, if we go back to this problem here, if we were decreasing x by 1/4, we're subtracting from 4/4. 4/4 is equal to 1. If we do the other, which is more than, or talking about an increase, then what we're going to do is we're going to add to 1. We're going to need a value more than 1 to stretch or increase that value, usually that x value, to equal whatever y is. So let's look at some of those situations. We'll do a couple and then I want you to try the rest. So we've got here at the top multiple equations, all in the same formation, starting with y, doing something to x to equal y. Now remember, with the hint that we just talked about, if this value, if this constant of proportionality is less than 1, then we're taking x and shrinking it. It's like having a scale factor less than 1. But if it's more than 1, we're going to take x and stretch it, increase it, so that it equals a greater y value. Let's look at the first example here. It says Elena biked X miles and Noah biked 2/3 more than that. So we could draw a situation here, but we really don't need to. We need to look for those key words. We're talking about Noah biking 2/3 more. Because thirds is our denominator here in the situation, that means that we're going to represent Elena biking X miles with thirds also. So if she biked X miles, all of X is going to be 3/3. That's what Elena biked. Noah, because we want to have that same denominator of thirds, Noah biked 2/3 more. So we're going to add 2/3 to that. We're going to add to 1. This is our 1 that the hint was talking about. So we'll add 2/3 to 3/3, and that equals 5/3. So in total, Noah spiked 5/3 of what Elena did. Now, the difficulty here is going to be finding which constant of proportionality is equivalent to 5/3. We just need to divide. 5 divided by 3 is going to equal 1.6 repeating. There's our repeating decimal. Now, if you look on your calculator, a lot of times it's going to say 0.6666666, and there'll be a 7 at the end. That's because the calculator can't show you any more digits, and so it rounds the last number. A 6 is closer to rounding up, so it rounds that last number up to a 7 when it can't show you any more digits. But it's still really just a 6 that keeps going on and on and on forever. So we need to find that equation. It is right here, and that's going to be our answer to A. Y equals 1.6 repeating X. Let's look at Elena. Again, Elena swam X laps in the pool, and Noah swam 2/5 less than that. So X is our whole amount. This is our 1. And since we're using fifths as our fraction, then what we need to use for Elena is an equivalent amount to 1 using fifths, 5/5. Noah swam 2/5 less than that, meaning we're going to subtract 2/5, which is only going to leave us 3/5 for what Noah did. Now we just need a decimal. 3/5, well, 3/5 is equivalent to 6/10 is how I'm seeing this. You could divide 3 by 5, but 6/10 is 0.6, and that's going to be our constant of proportionality for this example. So y equals 0.6x. Now, I do want you to try the rest of these on your own, match up with what's left, so cross off the ones that you're doing. I don't believe there are any repeats here, and go ahead and fill those in before checking with the answers at the end of the video. If you have any questions about this, please ask on Zoom today. Make sure to get your practice problems done, and don't forget, in a couple days, you've got your weekly iReady lesson to finish up. So please get to work and let me know if I can help in any way. Have a good day.